Cairo is a new type of programming language that creates provable programs. That is, a program whose execution can be proven without having to re-execute it to compare results. This proof attests to the integrity of the computation. In contrast to Solidity, who runs on top of the Ethereum virtual machine, Cairo runs on top of the Cairo virtual machine. This virtual machine has a very different architecture to traditional virtual machines like the EVM, because it makes use of ZK circuits to generate a validity proof out of a Cairo program execution. Cairo's syntax is inspired by Rust, so knowing one language will help you learn the other. It's important to highlight that Cairo is only inspired by Rust. There are small differences between them, and the compilers have nothing in common, as one targets traditional CPU architectures while the other targets the CairoVM. Cairo has a similar ownership model to Rust that allows for high-performance execution without garbage collection at runtime. Because Cairo's syntax is inspired by Rust, the language is strongly typed, uses traits for code reusability, and macros for metaprogramming. This style of programming language is more flexible than OOP languages like JavaScript or Solidity, and allows for the creation of more complex programs. An interesting feature of Cairo is that it can be used outside of Starknet. Cairo is a true general-purpose programming language that can go well beyond just smart contracts. Think about that for a moment. Cairo opens the door not only to create smart contracts on Starknet, you can create any type of program with it. This opens the design space wide open and bolsters innovation. An example of Cairo used outside of Starknet is ZeroSync, a product that is able to prove Bitcoin's UTXO with the goal of synchronizing a new Bitcoin node in minutes in a trustless way. In my opinion, the best part of Cairo is that you don't need to know anything about ZK to take advantage of this type of technology. Cairo abstracts away all the complexity of ZK circuits, polynomial constraints, Fry protocol, etc. With Cairo, you can take full advantage of a CPU architecture built on top of ZK proofs without having to know how it works under the hood, so you can focus on the logic of your app.